Okay, so here in this, I'm going to work this one out now using a calculator. This is still a standard normal distribution. So my mean of 0 is in the middle. Here's -1 standard deviation, +1, -2 standard deviations, +2 standard deviations. -1.82 is about right here. Looks like that's right there. I'm looking for the probability that z is greater than -1.82, so I'm looking for the area to the right of -1.82. That's what we want in this problem. So how we're going to get this in our calculator is we're going to hit second in the upper left corner, and then we're going to hit bars to get distribution, DISTR. We're going to go down to normal CDF and hit enter. As our lower bound that's bounding our region, ignore what's purple there, but the lower bound that's bounding our region is that -1.82. So for my lower bound, I'm typing in -1.82. For our upper bound, we don't really have an upper bound because this region does not end. So I'm just going to put 1,000. We could put 1 million, we could put 10,000, we could put 100. We just need to put a very positive number to show that it does not have an upper bound, that the upper bound is very large. We do know that our mu, I don't know what that's doing sitting there. We do know that our mu is 0 because our mean is 0 in the standard normal distribution and our standard deviation is 1. I'm going to hit enter on paste, and I can see that I've typed something in wrong, so let me go fix that. Oh, very great mistake for me to make. You don't want to use this minus sign for your negative. You want to hit this negative down here if you're using your calculator for -1.82 when you're putting in your lower bound. And then it gives us about 0.9656 for our answer. So really quickly, what I had put into the calculator, it was down here. Sorry, I know y'all are looking at a bunch of stuff right now. I'm making a bunch of videos at the same time. But this is what we put into the calculator. Normal CDF, -1.82 for our lower bound, 1,000 for our upper bound, 0 for our mu, and 1 for the standard deviation. And what this gave us out in the calculator was about 0.9656. And that's our answer, which is the same thing that we got when we used the standard normal distribution tables to look this up.